Welcome everyone. Today we are looking at why platter is better in implant dentistry. It is important to remember that the implants lack the periodontal ligament that makes them less forgiving. And Weinberg has stated that for every 10-degree increase in the cuspal inclination, there is approximately 30% increase in implant prosthesis loading. The major cause of implant prosthesis failure after phase 2 surgery is attributed to implant overload due to steeper cuspal inclination. Controlling the cusp angle of implant prosthesis is therefore critical for long-term success and clinical longevity of the implant prosthesis. The angulated cusps generate detrimental angled loads to the implant system. The flatter cusps direct the occlusal load to pass nearby the implant body, while as the angulated cusps deflect the resultant line of force away from the center of rotation of implant body. The greater the cuspal inclination, the greater the deviation of angular loads from the center of rotation of the implant, and vice versa. This deviation increases the moment of multiplying the torque at the bone implant interface and leading to crystal bone loss. The let the cuspal inclination of the implant crown is theta, and the load of L is applied to the implant process. The resultant line of the force deviates from the center of rotation of the implant by a distance of d. Hence, the torque acting upon the implant prosthesis shall be Fd. C. On increasing the cuspal inclination by 10 degrees, this alters the working arm distance to d, as is shown here. Now the new torque acting upon the implant prosthesis becomes Fd. According to Weinberg, the final torque is more than the initial torque by 30%. Altering the cuspal inclination relative to the occlusal load changes the working arm distance, creating a lever effect that intensifies the torque acting upon the implant prosthesis. Think of it as a lever. The farther the force moves away from the center of the implant body, the more leverage is exerted against the bone implant interface. Let us plot cuspal inclination along x-axis and the percentage of change in the torque along y-axis. The torque acting upon the implant prosthesis at some degree of cuspal inclination is shown as a bar. The moment we increase the cuspal inclination by 10 degrees, the torque acting upon the implant prosthesis is increased by 30%. The process repeats itself if we keep altering cuspal inclination. This is the rule of thumb to remember that a 10-degree cuspal inclination means 30% more load. The lab must be authorized to make flatter cusps to reduce the overloading and increase the clinical longevity. The treatment planning must prioritize cuspal inclination before prosthesis insertion. The implant crown with high cuspal inclination and narrow central fossa deflects the resultant line of force away from the center of rotation of the implant body. Upon occlusion with opposing anatomical cusp, it may be necessary to recontour the opposing natural cusp to occlude in the central fossa over the implant body. If the implant crown mimics the natural cusp angle, premature contact will occur on the cuspal incline, and the resulting direction of load may be 30 degrees to the implant body. Selective recontouring of the opposing dentition ensures axial loading. On the other hand, the widened central fossa of the implant crown directs the occlusal load axially. The occlusal contact over the implant crown should be ideally flat on surface perpendicular to the implant body. This positioning is accomplished by increasing the width of the central groove to 2 to 3 millimeters in posterior implant crowns and positioned over the center of the implant abutment. This creates a stable axial load receptor.